explain this one in detail.
Hi. The question 3 in homework 1 is my duty. And this question it asks you to find the disparity map based on the left and right images here. So this is the right image and the left image and right image.
And the result is disparity. The third one is the disparity.
Yeah, the third one is the disparity map. So if you demo the question 3, I will offer you the left image in PNG data type, and right image also in PNG type as input. Then you should show me the stereo disparity map as an output. And this is the button. You need to do the image left and right separate, and click the button to show the third image, the display map. And here's the hint. You can use the class in OpenCV, which called stereo BN, to build the object.
BN probably block matching.
Yeah, block matching.
Block match.
Yeah. And
block is a window, called window. Block is a window.
Yeah. And the second point is you need to initialize the objects. Here I call it stereo with the argument number of disparity 432, and the block size 25. And usually the number of disparity, it will be less as large as this.
No. Usually the disparity usually at 64.
Yeah, less than 64.
通常 disparity 不会那么大。注教这是表示两个视差。This case the disparity is too large.
Yeah.
Usually it's only like 64.
Yeah.
Or probably sometimes, but not too many. It's a 128 disparity, but that's already really
too big.
And the block size usually is 3 by 3. That's a small window.
Yeah.
3 by 3 usually. But sometimes my experience use 5 by 5 sometimes. If we use such large, because most of the case we do stereos in real time. But if the block is too big, it cannot be real time. It will be very slow, because each pixel you need to do the search. Okay. So in order to speed it up, we use the 3 by 3 or 5 by 5. 7 by 7 is already too big. So the same as deep learning.
Okay, then the third step, you can call the method in the stereo and put the left image and right image as the argument. Then you will show the output disparity. Yeah, and in OpenCV, you need to normalize the disparity map in 0 to 255 in the range. Otherwise, you cannot show the image in OpenCV.
Okay, the disparity in this case, the disparity is the real value. So disparity in this case, if your search range is 432, that's meaning your disparity probably 0. 0 is meaning you don't have a disparity, it means infinity. If the pixel in the infinity, okay, and the disparity will be 0. And if closer, the disparity will be large. So in this case, probably disparity is very large. But I'm wondering. Is so the large display probably 432 is large, but that's a real value. But for display on the screen, this one, you need to normalize from 0 to 432, mapping to 0 and 255 gray value. So the gray value just for people to see the display result, but that one is not the real value. Okay. And the purpose for stereo is we try to find Z, right? The best Z. So test Z in my lecture, Z equal to F times B space 9 divided by disparity. That's Z. So Z actually is our purpose. The same as the Intel RealSense. If you buy the RealSense, they will give you the Z. But RealSense, they use stereo, gray value stereo. So RealSense is using stereo, the same as this one. So they find a disparity. They know the baseline. They know the focal length of camera. So after they find a disparity, they will transfer to Z, the real depth. So again, this gray value just for people to see the result. So if the more bright, I mean large disparity is close to you. If there is a dark, the black is far away from you. Okay.
Yeah.
真的是443。
就是试下来这个最好看。And here's some comment about the argument. The first one is the number of disparity. It should be positive and can be divisible by 16. And the block size, it should be odd and within the range 5 to 51. Also, the large block size will smooth the disparity map. And the smaller block size, it will be look like noise. So you can try different arguments if you like. And also, both the input image are in this size. The width is 28.
Oh, that's very high dimension.
High resolution. 2816 and 1916. It's the if you do the demonstration, I will offer the image in this size.
Usually we don't use such high dimension because high dimension the search range will be big.
Yeah.
Right. So usually we would use like a no more than 1200. 我们通常解析度不会超过1200啊，就是1200，就是大概2K 了，1200乘1000，这已经够大了。
Okay, then next. This is my demo. So the left image and right image. Then compute. Any questions?
没有结果。
有。
不是。哦 ，OK，这样。
The left, you should show 3 images to me. The left image, the right image, and the result, the disparity map. So any questions? Okay, good.
The question 4 is shift. We'll find shift key points and match key points. 4.1 is shift key points. We'll click button load image 1 to load the image here and click the button key point to show the output. First, we convert.
Let's see. Speed. Let's explain one by one.
So first, we'll convert the image to grayscale image, we can apply cv2.cvt color and put the argument. Okay, second, based on SIF algorithm, find key points on depth.jpg. We use OpenCV SIF detector to detect key points and descriptors. We can apply cv2.zip create to create a SIF detector and use detect compute to get key points and descriptors. And
output will be descriptor and key point.
yes,
Key point is the position, right? The green dot is a key point,
yes,
and descriptor is a 128 dimension vector. Right? So each key point, the position will corresponding to one vector. This vector is a 128 dimension. That's meaning the feature vector. 它特色，它这个每个 key point 就有一个 block， 那这 block 就是会用一个128维来描述这个 block 的特色，这样子，那叫 descriptor， 就对。
Then we use draw key points, the function here to draw the key points, and you should show the image.
就做了 ，so key point 是 one point， right？ 对吧？好，然后 RGB because G is 255 is green。
Yes. Four point two is match key points. You should click the button load image here to load the left.jpg and click the button load image to load the right.jpg and click the button match key point to show the output. So first, based on SIF algorithm, find the key points and descriptors at image 1 and image 2. It is same as question 4.1. Second,
So for in left and right image, you need to find the key point first.
and descriptors.
A descriptor.
And by matching points, you can apply the cv2.vf matcher.kn match to find the matches. And the matches here is a 2-dimension list. It means M is the nearest key point and N is the second nearest. So the argument K equals 2 here, we've got the 2 nearest match key points for each key point. And in these 2 match key points, we apply ratio test. So if the distance to the closest match is much smaller than the distance to the second closest, the match is considered good.
This one, right?
Yes.
Explain this one.
Yes.
Explain a bit.
So for the MN matches, M is the nearest match key point and N is the second nearest. So if the M distance and N distance, the ratio is lower than 0.75, it will be considered good matches. So we append it for good matches list. And the distance here doesn't mean the physical distance. It's just a value.
Similarly,
It's just a value means that the lower the value is, and it is more similar to the key points.
so that's distance is the similarity
Yes.
based on the descriptor.
Yes.
Okay. So that's meaning that just suppose in the left, you will match 2 points on the right.
Yes.
And then based on the similarity, So if both are, compare with each other less than 0.75, and then will be
And
good match.
yes, the M and N is the two nearest match key points.
What's the meaning? So good match. You 1 point match to 2. And which one is the
Nearest.
small value?
Yes. And
Smaller less
second.
than second bigger value. So it's a much smaller. So that's meaning 2.1 match to 2. But one is large, the other is one is very small. The other, both one is smaller than the other one. That's good match. So if both are similar, that is meaning doesn't mean a good match.
Yes.
So it's unique, right?
Yes.
So one match to 2. Hopefully, one is a very similar, the other is not so similar. So that's good match. Yeah, that's physical meaning. Should you explain that one? Explain the physical meaning. 所以它的单一性，它只能 match 到一个独一的嘛，它不需要两个 confuse。
对，
好吧，这样写这在物理你后面有写是不是？
It's a ratio test. So let's you apply draw CV2.draw match KN to draw the match key point and show the image here.
So it's a draw the result.
Yes.
Okay. Good match.
And this is the demo video. You load image 1 and show the key points. And load image 2 to show
So that's the result.
yes.
Good. Thank you. SIP is very important. And remember right now, deep learning has a new method for the descriptor. It's better than SIFT and it's faster. So, let's say again. So SIFT can do this. It's one example. So it can be in real time. It can be so corresponding point, meaning both images are similar. They can do the real time, and they can partial occlude it and still can find the matching. Okay. This is one example. And class, in the lecture, I will also tell you they can do stitching. 它可以做拼图用， so stitching using the SIFT, the same thing. 它应用面非常广，所以 SIFT 这种 descriptor is very important. 好，赶快回来教这个，把它教不完。We continue talk about SVM.